Hello friends, welcome to another session. I am Orko. So if you are visiting this channel for the first time, if you know what we do here, we talk about the quant topics that's relevant for Indian MBA entrance exams, primarily focuses on CAT, NMAT, SNAP, IFT, that kind of exam. If you are not preparing for MBA but still preparing for SSC or a bank PO kind of an exam, you can still cover these topics. We at least the first two sessions. So as you know, we cover each topic in three sessions. The first session is typically on the fundamentals, where we talk about the concepts, absolutely make the concepts crystal clear. Take few examples to cement those concepts, but not too many problems we do in the first session. Focuses only on concepts, formulas, theories that you need to remember. And then on the next session, we go to the problem level session one, which is primarily focused on the understanding of the concept, applying those concepts in some simple problems, some complex problems, some different scenarios, typically level one, level two kind of problem. In problem session two, we go and solve around complex problems or little advanced level problem or little trickier problems at times. So if you are preparing for non-MBA, you can focus on the fundamental and the problem level session one. Problem level session two is typically focused on the preparation of MBA entrance exams in India, where we do little complex or little tricky or little, some extra exceptions that we try to solve, and that's where the problem level session two comes in. But yeah, this is the typical flow. So today we are going to talk about inequality and modulus, which is again a very important topic when it comes to your CAT and MAT, SNAP. After all the MBA entrance exam invariably has two to three questions coming out of inequality and modulus. So you may not have one questions right away only focus on inequality, but there will be a bigger problem, or there will be a different problem where inequality is applied. So there is a maximum minimum problem, there is a quantity equation problem where inequality is there. So let's get started. Let's clear the concepts in today's session. So today we are going to talk about the fundamentals. So this is the first session of inequality and modulus, right? So we are going to talk about the fundamentals of inequality and modulus. So without further delay, let's get started. So what we are going to cover is what we learned till now is the simple equation and quadratic equation. And in quadratic equation, I give you some hint of inequalities, but no matter if you have seen that, it's good. Otherwise, I'll recover whatever we have covered in the previous session in terms of inequality, that I'll cover here again. So no need to worry about that. So what we know in an equation kind of a scenario, if you have typically x minus 3 equal to 5, then we know the solution is x equal to 8. So this is normally a scenario of an equation. Now, if I can say x minus 3 is greater than 5, then it is non-equality. We don't get a single solution like this. So here we are getting a single solution. Here we are getting x greater than 8, which is a range of solution. Range of solution. Right? So it's not a one solution like this one, but it will be a range of solution that we get. Now, let's take a simple example. Let's say x minus 3 and x plus 5 are less than 0, right? Now, in this case, we know how to find. So, what are the values of x? What are the range of values x can take? Typically, this is one type of inequalities. Now, if you see typically, starting from very basic, what we know is both of them, one of them has to be positive and other has to be negative in order to make it less than 0. Both of them cannot be positive. This and this both cannot be positive, then it is more than 0. Both of them negative, then also it is more than 0. So one has to be positive, the other has to be negative. So let's get started. So what we are trying to do is x minus 3 is positive, and we can say x plus 5 is negative. So we can say x is greater than 3, and at the same time x is less than minus 5. x is less than -5, right? So if I combine these two, can you see any common range? No, right? Because x is in a one side I'm saying x has to be greater than 3. In the same scenario I'm saying x has to be less than -5. Both of them does not give any range. So this is not a fair assumption. So the other assumption is x minus 3 is negative and x plus 5 is positive. And if I do that, x is less than 3 and x is greater than -5. So then I can say -5, x and 3. So x lies in this zone. So this is the range of value of x. So this is one way you can solve it. The other way, so this is one way of finding out the range of x. You can consider individually what should be both of them, positive negative combination or negative negative combination, depends whether it is more than 0 or less than 0. The other simpler way of doing it is, if you have x minus 3 into x plus 5 less than 0, so that means if it is, if instead of less than, if there is a equal to sign, then the values of the roots of this equation is x equal to 3 or x equal to -5. Now, if I put this in a line, in a number line, so this is 0, here it is 3, and here it is -5, right? So then what we are seeing is, forget about the 0 as a separator. We are getting 3 regions, right? One region between this 3 to 5, the other region is this more than 3, and the other region is this which is less than 5. So if there are two solutions, then that two solutions divide the number line into 3 regions. One is below 5, -5, one is above +3, and another is between -5 and 3. Now, for the simplicity, what you can do is you can put 0. 0 lies in the range between 3 to 5, 3 to -5. So if you put the 0 in the equation, what you will get? 0 minus 3 into 0 plus 5. So what I will get -15, -3 into +5 -15, which is less than 0. So 0 actually satisfying this inequality. If putting 0 in the equation satisfying this inequality, so then this range, the range that contains 0, is basically the range for x. So this is satisfying, then this alternate areas will not satisfy. So if you see typically, if one area is less than 0, the other two area has to be greater than 0. So this space we are saying less than 0, this will be greater than 0, this will make it greater than 0. So it's alternate. So basically, if this area may give you a negative value, this area, any value in less than -5 will give you positive, any value more than -5 will give you positive. So this is an alternately positive negative kind of scenario. Why it happens? If you recall typically your quadratic class, we said this is a quadratic equation, right? So we said ax square bx plus c is typically equal to 0, is typically a parabola. Now a parabola can be upward inverted parabola. It can cut the x-axis into two places. Similarly, and these both are for a greater than 0. If typically a is less than 0, it becomes an inverted parabola, right? Or it typically becomes a parabola like this, right? Where it just touches the x-axis, Now, if you see typically, if it has two different solution, you see there are 3 different set of values, right? Between the two different solution, if it is negative, the other two side, so this side it is positive, this side it is positive, right? So once it goes beyond the x point where it cuts x, all the values of x, it will be positive. When it goes on the right side also, for all the values of x, it will be positive. So it is an alternate. So in between these two solution, it is negative. Towards the left, it is positive, and towards the right also, it is positive. Similarly, for here, the inverted parabola, if you see, between these two values, here it will be positive. So this is positive. Other than that, if you take a x value here, the parabola will have a negative value here. So this part is negative, this part is negative. So it will always be negative, positive, negative kind of a scenario. So if one region is negative, the alternate region will be positive and the other region will be negative. So if the mid region is positive, the other two regions will be negative. So that way we can solve that. So let's take another example for you to understand. Let's say I write x square minus 4x plus 3 less than 0. So then it will become x minus 1 into x plus x minus 1 into x minus 3 less than 0. Now, if it is less than 0, if I put in a number line, and I'll just directly put in a number line so that you can understand. So this is 1 and this will be 3. So the two roots of x will either be 1 and 3. Sorry, this will be 1 and this will be 3. So I have 0 on the left hand side of 1. So let's say this is 0. If I put 0 in this equation, what I'll get? If I put 0 for the first one, I'll get minus 1 into minus 3, right? So this is 3, which is greater than 0. So 0 does not satisfy my equation anymore. So this region, so by putting 0, I'm saying this region is typically positive. So the region between 1 to 3 should be negative, and region more than 3, this area is again positive. And what I need to know in the equation is negative because this is less than 0. So minus 1 to 3. So I can say 1 less than x less than 3. So x has to lie between 1 and 3. Right? So x has to lie between 1 and 3 to satisfy. Right? So how we can write it? The one way we can write is x belongs to 1 comma 3. This sign means belongs to. Right? Okay. Let's move on. Let's take it. What if it is a cubic? So let's say you have x minus 3, x plus 5, and let's say x minus 1 less than equal to 0. If you have this equation, how we are going to solve it? So again, the same rule apply. What are the three roots of x from here? I can say x can be 3 here, minus 5 here, and 1 from here. So if I put it in a number line, let's say this is minus 5, this is 1, and this is 3. Now again, let's put 0 in the equation. 0 lies somewhere here. So let's put 0 in this equation. So you get minus 3 into 5 into minus 1. So that means you get 15, which is greater than 0. So with 0, then this zone, the zone that contains 0, which is minus 5 to 1, is positive for me. Right? This part is positive for me. Then beyond minus 5, this zone will be negative. Then this zone will also be negative. Right? But after 3, then this zone will be positive. So now, if I have 3 roots, that means there are 4 different zones that have created. So this first zone, if this zone is positive, then this zone will be negative, this zone will be negative, and this zone will be positive again. So, right? So these are the 4 different zones, and it will be alternate. What I need to know is less than equal to 0. So I can say I am focused on the negative zones. So I can say x belongs to minus infinity to 5. X belongs to minus infinity to 5. And similarly, I can say x belongs to 1 to 3. So these are the 2 zones that giving me a negative number. Now, what you need to understand is there is an equal to sign. So equal to signs means we can say minus infinity less than equal to x less than equal to 5, 1 less than equal to x less than equal to 3. So these are the 2 solutions of x. These are the 2 zones of x which will satisfy this equation. right? In the again, recall the difference between giving a first bracket and a third bracket. So this will ideally be a third bracket. When I say third bracket, so basically if I say X belongs to A comma B, that means A and B are not included. When I say X belongs to A comma B in a third parenthesis, that means A and B are included. Similarly, if I say X belongs to A comma B, and with A I have a first parenthesis, with B I have a third parenthesis, that means A is not included, B is included. Similarly, the last part, if I have A with third parenthesis and B with first parenthesis, then A is included, B is not included. So whenever there is a third parenthesis, that means that value is included. Which one has the first parenthesis, that means that value is not included. Since there is a equal to sign, that means both the range has to be included. Hope this is clear. Let's move to the next one. Okay. Now, one important thing that you need to understand is, let's say I have, let's do a couple of problems. Let's say I have x minus 3 and x plus 5 by x minus 1, which is greater than 0, right? So if I have this kind of problem, what I need to do is, if I don't know x minus 1 is positive or negative, let's say there is a by b, or which is greater than 0. Can you say always a greater than b? No, right? Because let's say a by b is 3 by 2, right? This is greater than 0. So from here I can say 3 greater than 2. Now what if uh, a by b is minus 3 by minus 2, which is also greater than 0? But can I write minus 3 greater than minus 2? No, right? So a by b greater than 0. So I can say a by b greater than 0. This can be implied as a greater than b if a and b are positive. This implies a less than b if a and b are negative, right? So this actually means minus 3 less than minus 2. So if there is a negative sign, the inequality gets reversed. So with this equation, we can't say directly whether it is going to be right away. I can cross multiply x minus 1 on the right side with 0 and keep the same sign. So the better way of doing this kind of problem is, when you are not sure whether x minus 1 is positive or negative, or your AB is negative or positive, you just multiply both the side with b square. So when I say a by b less than 0, greater than 0, you just multiply a by b with b square, and similarly 0 into b square, right? So that means what happens is this gets cancelled and becomes ab greater than 0. So we can write, for if a by b is greater than 0, we can surely write ab is greater than 0, right? So this is a very important understanding. A by b greater than 0 is same way of telling AB is greater than 0, right? So if you understand this part, then let's see how we can do this problem. Just a minute. So this problem, what we need to say is x minus 3 into x plus 5. Let's consider the top part is a. This into x minus 1 has to be greater than 0. Now it's the same approach you can apply like the previous problem and solve. So here in a number line, typically it will have 3 roots, 1, 3 and minus 5. And then if it is greater than 0, you can again check with 0 and go ahead with the same solution. So I'm not going into depth of that, but that's how you can do it. Okay, let's go to the next problem. Let's move towards a little bit of a different inequality. Let's say you have to find out 70 to the power 71 or 71 to the power 70, which one is higher. Now, before doing that, there is one formula that you need to remember. If 1 plus 1 by a whole to the power a, this always lies between 2 to 2.8. This is a very important understanding. We can calculate this and we can show you, but understand for now 1 plus 1 by a whole to the power a. This is the form that lies between 2 to 2.8, right? So, and this is valid only when a is greater than equal to 1, right? Just let me confirm if it is greater than, yeah, a has to be greater than equal to 1 to get it satisfied. Right? So with that, if I from here I can write 71 to the power 70 by 70 to the power 71. So if I take 1 by 70 out, then it will become 71 to the power 70 by 70 to the power 70. And if I take 1 by 70 out, then I can write this as 71 as 1 plus 70 whole to the power 70 by 70 to the power 70. So I can write this as 1 by 70. So this will become 1 plus 1 by 70 whole to the power 70. Right? Now this part, if this part is same as this part, so this is basically can be written as 1 plus 1 by a whole to the power a. So this part, if it is lie between 2 to 2.8, that means can I write this value is 1 by 70 and 1 by 70, and then it's multiplied by between 2 to 2.8, which is, let's say, less than 3. If it is multiplied with a number which is less than 3, then can I say this value is less than 1? Because your numerator is less than 3. So which maximum value you can get is 2.8 by 70, which is less than 1. So can I say 71 to the power 70 by 70 to the power 71 is less than 1, or 71 to the power 70 is less than 70 to the power 71. This is the higher number. Right? From here, there is also a derivation that you can say is this is also a very important derivation. A to the power a plus 1 is always greater than a plus 1 to the power a for a greater than 2. If a is not 1 and 2, then this will satisfy. Or a greater than 2. So this is another very important corollary or very important formula to remember. So remember these two formula. A lot of this kind of problem with power with exponents gets solved through this. Okay, and we will solve some of this in the when we do the problem sessions. Okay, now let's solve a cat kind of a problem. Okay, but before that, I just want you to cover, you are currently with me. If you have any particular doubt or any particular query where you are not clear, please drop a note in the description box and we can take it forward from there. Okay, now we can solve a particular query, but let me first cover the modulus, then I'll come back. So let's say now go to modulus first. Let's try to solve the modulus, and then I'll try to see if we can solve few more problems in inequality. But with inequality, what we understood typically, let's do a quick recap. What we did here is, so we started with a basic understanding of what is from equality to inequality, how it changes. Then we find out what are the defined regions that is there in a quantity equation. There are two solution of x. That means there will be 3 region created, and the alternate region will be positive and negative. Based on what you need to take, you will choose that solution. Then from there we go to the 3 variable this is another example of quadratic. This is the one where we have got for three variable, we got four regions of x, and then alternatively we have seen it is negative, positive kind of a scenario. Then what we did, we took one more example where we understand that a by b, a greater than 0 is same as written as ab greater than 0, because I'm just multiplying both the side with b square. But don't write from here always a greater than b is not always true. Not always. So this is not always. So this is an important learning that you have. Then from here we went out and understand how these two formulas typically work. Okay. Now let's move to the next problem with modulus. Now what is a modulus? A modulus is basically talks about distance. Now if I write mod x means distance of x from 0, right? So if I write mod x equal to 2, that means distance of x from 0 is equal to 2. So that means we can say in a number line, if this is 0 and this is 2 and this is minus 2, when I say distance, it can be in either side. So x has to lie between in this zone. So can I say mod 2 less than equal to x less than equal to 2, right? So mod x is equal to 2 and written as x equal to 2. If it is, this is when there is an inequality sign typically, but when mod x is equal to 2, you can write x equal to 2 or x equal to minus 2, right? So these are the two possibilities. X can be equal to 2 or x can be equal to minus 2. So in a generic term, if I say mod x equal to a, x can be a or x can be minus a as well, right? So these are the two things that is very important from understanding of mod. Mod is always talks about distance. That means it's irrespective of the sign, the distance kind of remains same. So if you go to 0 to minus 2, you have covered two distance. 0 to 2, you have covered two distance, right? So typically then what we can write is mod x. Mod x is typically x when x greater than 0 equal to minus x when x is less than 0, right? So this is the distance of that particular point from 0. So if what I mean, mod 3 is 3 or minus 3 depends on what is the value of that, what is the internal value. So if you take a modulus of 3, it is 3. If you take a modulus of minus 3, then also it is 3, right? So similarly, if I say mod x is less than equal to a, if mod x is less than equal to a, then what it means is the distance of x from 0 is between a is cannot be more than a. So in this case, if I write mod x less than equal to 2, if you see the previous example here, what we have written, so x distance from 0 cannot be more than 2. So if this is minus 2 and this is 2 and this is 0, x has to lie in this zone. So I can say minus 2 less than x than equal to 2. So from mod x less than equal to a, we can say minus a less than x less than a. So this is an important understanding. What do you mean by mod x less than equal to a? All right. Now, if I have mod x greater than equal to a, that means x is always the distance is more than a. So it's the same way of writing mod x greater than 2. So in the number line, I have minus 2 and 2. This is 0. So x has to lie somewhere beyond minus 2 or somewhere higher plus 2. So x has to lie in this zone, right? So I can say minus infinity less than x less than equal to minus 2 or 2 less than x less than equal to infinity, right? So this is when mod x is greater than a. So from here I can say x is either less than minus a or x is greater than equal to a. So this is another important understanding. So these two are very important when it comes to mod. So understand it's always about distance. So when I say always about distance, it's either the distance needs to satisfy. When I say mod x greater than a, that means the distance of 0 to x has to be more than a. So if it is 2, that means the distance has to be more than 2. So x cannot be between 0 to 2. So the distance is less than 2. It cannot be like that. It has to be higher than 2 on both sides, on the minus side or on the positive side. Here we are not typically for things gets changed if it is sign changes, because modulus talks about distance, and I'm focusing on distance because distance is the key understanding here. Okay. Now let's take one example and see if we can understand this a little better. So let's say you have mod of 2x minus 5 less than equal to 9, and mod of 3y, not 3y, let's say 4y minus 7 less than equal to 21. Okay, you can find the max of mod x minus mod y. So this is one kind of a problem, right? So from here, if we remember what we said, the mod x less than equal to a, that means minus a less than equal to x less than equal to a. So mod of 2x minus 5 less than equal to 9 means minus 9 less than equal to 2x minus 5 less than equal to 9, right? So if I put plus 5 on both the sides, then minus 4 less than equal to 2x less than 14, or I can say minus 2 less than equal to x less than equal to 7, right? On the other side, I can say minus 21 less than 4y minus 7 less than 21. Again, applying the same logic here, then I can say minus 14 less than 4y less than 28. So minus 14 less by 4 less than y less than 7. So what I need to do, I need to max out mod x minus mod y. So that means I need to find out the max of x and mean of y. That's when the difference is maximum. So max of x is 7 and min of minimum value of y is what? Think and tell me what will be the minimum value of y. So y lies between minus 14 by 4 to 7. Now think, if I put minus 14 by 4 value of y with modulus, it will become plus 14 by 4. So then it is not a minimum. So the minimum value of any modulus is always 0. That distance is 7. Understand this? Minimum value of any modulus is 0. So what I learned from this problem, minimum value of modulus is always equal to 0. Individually, that number can take negative value, but a modulus of any number cannot be negative. So since it is a distance, the minimum distance has to be 0, right? Okay, so this is an important understanding. Before we move on, there is one important part. When I say mod of x, we talk about the distance of x from 0. So this is from 0 distance. When I say mod x minus a, then distance from a. So for example, when I say mod x minus 2, then this is the distance of x from 2, not from 0. So ideally, this is the way you can read it. When I say mod of x plus a, then distance from minus a, right? So with this, what we can do, let's take one example. So let's say there is an equation. Let's say fx is equal to mod of x minus 2 plus mod of x minus 5, x minus 5 plus mod of x minus 9. So this is a rule. So this is an, let's say this is an equation or an expression. Now can you find out what is the minimum value of fx, or what is the minimum value of this expression, so this is a cat problem. I think cat 2002 or 2003, when it has came. I remember this problem because when I preparing, this is one problem I that actually helped me understand this modulus in a very good way. So when I say mod of x minus 2, that means it represents the first part. Let's me go to the next page. So x minus 2 plus x minus 5 plus x minus 9. I have to find out the minimum distance. Now, the first one represents the distance of x from 2. So this is represents the distance of x from 2. This represents the distance of x from 5. And this represents the distance of x from 9. Now, if you think typically, now where you can place x, x can be here, x can be here, x can be here, x can be here. So 3 roots, then there are 4 regions. In one or any one of the region, x can fall. Since I have to find out the minimum value, then I have to find out the minimum distance. Now, in order to find out the minimum distance, I know if I put x beyond 2, then from 2 there will be a distance of x. From 9 there will also be a distance of x. So that means you see this zone, let's say x is here, right? If x is here, so this particular zone is calculated for 2, this particular distance is calculated for 9, and for 5 this particular zone is calculated. So this particular zone, and similarly this particular zone is calculated for 5, and this calculated for 9. So there are multiple calculation of the same zone or the same distance. So that means this cannot be a negative if x is on the leftmost side. Similarly, if x is on the rightmost side, you can see you will calculate this zone for 9, you will calculate this zone for 2, you will calculate this zone for 5. Because 9 say this is the distance, from 2 also this will be the distance, from 5 also that will be the distance. So this typical zone gets calculated 3 times. Similarly, this particular zone will be calculated for 5. When you calculate for 5 means when you calculated the distance of 5 from x is here, the distance from 2 from x is here. So this particular zone is calculated twice for 5 and 2. So you calculate the same zone multiple times. So it cannot be this side or it cannot be this side for the minimum value, right? So the option that I have, let me just simplify this. Yeah. So the option that I have now is somewhere between 2 to 9. Now somewhere between 2 to 9, let's say I take it here, let's say around 4. So for 2, this is the zone. From 5, this will be the zone. And for 9, this will be the zone. But then also you see, this is a small place. This is a small place where I calculate the zone distance for 5. I'll also calculate the distance for 9. So even if it is between 2 to 9, there will be a small zone that is overlapping. Now the idea comes, why can't I keep it at 5 itself? So when I keep it at 5, the distance of that is the distance for that from 2 is this much, distance from 9 is this much. None of the places I am calculating twice, and from 5 it is at point, so from 5 it is 0, right? So the minimum value will come when x is at 5. So when x is at 5, your first part becomes 3, second part becomes 0, and the last part becomes 4. Minus 4 because of modulus 4. So the minimum value is 7. Right? This is the distance between 2 and 9. Right? So now you can tell, why can't I put it at 2? If you put it at 2, that means this particular area you will calculate for 5, because 5 to 2. And this same particular area, this zone, will be calculated twice. So you can't, similarly, you can't put it for 9. So 5 is the zone where you need to put. Okay, so that none of the areas get calculated twice when you are looking for a minimum value. This is a very important understanding. Okay, we'll solve more problem like this when we take the problem sessions. uh, okay, let's move on to the next set of formulas, and these are possibly the last ones we are covered today, and this is very important. So let's say a1, a2, a3, these are all real numbers, and this is only valid for real numbers, the formula that I'm going to tell you. Number one, if sum of all these numbers are constant, if a1 plus a2 plus a3 till let's say an, if all the sums are constant, then the product, the product which is a1 into a2 into a3 till an, so then the product will be maximum when a1 equal to a2 equal to a3. So when all the values are, when sum are, basically what I'm trying to say, if the sum is constant, then the product will be maximum when all the values are equal. Similarly, if my product is constant, if the product is constant, then the sum, which is a1 plus a2 plus a3, will be minimum when all of these are equal. Remember, when sum is constant, the product is maximum, not minimum. The product is maximum when all of them are equal. When the product is constant, the sum is minimum when all of them are constant. Remember, but this is maximum, this is minimum. Okay, so this is a very important understanding. Okay, now the third part is, always remember, AM or arithmetic mean is always going to be greater than geometric mean, which is always greater than harmonic mean. So I will cover what is AM, GM, HM in depth in the progression class. But for now, let's say there are three numbers A, B, C. For their arithmetic mean is A plus B plus C by 3, which is nothing but their average. Geometric mean is cube root of A, B, C. And harmonic mean is 3 by 1 by A plus 1 by B plus 1 by C. So this is harmonic mean. So AM greater than GM greater than HM for all the possible cases. Okay. The other two formula we need to remember is number 4, which is A plus 1 by A is always greater than 2 if A is a positive number. It is equal to 2 if A equal to 1, then A plus 1 by A is equal to 2. For all other values, it will be more than 2, right? Similarly, I can say A plus 1 by A is less than equal to minus 2 if A is negative. If A equal to minus 1, then we can say A plus 1 by A is equal to minus 2. So what underline you need to understand is A plus, sorry, if A is greater than 0, A plus 1 by A is minimum when A is 1, because that's the minimum value of 2. Similarly, if A is less than 0, A plus 1 by A is maximum when A is less than, sorry, when A is equal to minus 1. Because minus 2 is the maximum value, all other values are less than that. Okay. So these are very important type of problem that you need to understand. And we will solve quite a few problem in the next session covering some of these concepts. But I hope you have understood the fundamentals of inequality and modulus. And once we do the problem sessions in the next session, it will get further cemented. So follow up. So do see the next video, and please feel free to drop a note if you have any doubt or any clarity needed somewhere. Uh, okay. So hope you have a good session. You learned something new. And if you like the video, please like, share, subscribe for the algorithm and for my own motivation, because it takes time to research on what needs to be covered. And we typically don't cover it in 1 hour, 2 hour kind of a session. We try to keep it focused and try to keep it very objective oriented, and try to build it in small nuggets so that you can consume and you are not with inform go out of this video or the session with an information overload. So go back, process this information, try some of the problems, type of the problem, and in the next session we will solve problems where your understanding gets more and more strengthened. Okay. So thanks. If you want to reach out to me, you can reach out in the mail ID given in the description box, or you can drop a comment in this video. I will respond. So, thank you. See you next time. Bye.